As you recall, last week we delved into some of the design considerations in pavements. And then the main thing was to recognize the different pavement types. This is just a recap of the previous thing we did. I'll just take a few minutes here. And then we also discussed how to understand the role of the pavement and the soil layers. And then we identified key factors that affect the performance of the pavement. We just went through what we did last week. And I said we tried to differentiate different types of road pavements. And they wanted to understand the role of the pavement and soil layers, and also to identify key factors that affect the pavement performance. Now, we spoke about rigid pavements, and we said they are Portland cement PCC slabs that distribute wheel loads over large areas. And we also said that they could be placed over a prepared subgrade base or a combination of base and sub-base courses. We also discussed flexible pavements are those that deform symmetrically and they distribute wheel loads through various layers. We also spoke about cobblestone or brick pavements, and we said they are common in many localities, but from a structural point of view, they are different, even though they are designed as flexible pavements. We mentioned composite pavements, and we said they could be rigid pavements with an asphalt concrete overlay or composite pavement with an asphalt concrete overlay. Then also, we spoke about different types of factors that affect pavements. And we spoke about traffic, we spoke about subgrade strength and everything. But we didn't delve into the drainage considerations. So today, that's what you are going to look at. You are going to look at drainage considerations. You are going to look at surface drainage. You are going to also touch on subsurface drainage, and then look at filter cloth or engineering fabric in brief. Now, after traffic loading, realize that the next most important damage that affect our road pavement is moisture. So if you have water in your road pavement, then you are in serious trouble. So one always has to be careful about moisture in the pavement. So if you have a deficiency in your pavement that is developed because of defective drainage, you cannot correct that by maintenance works unless you have solved the drainage problem. And we have some of them, some examples all over the place. A typical example is around Ashama roundabout. If you are going towards Afienya, just after the roundabout, you see that you have an area of about 100 meters, which is always a bad part, simply because the pavement layer there has been worn off. It's lower than the sidewalk and the inlets that allow the water to flow. The inlets are all silted, and the water cannot flow out through the curbs and the gutters into the drainage system. So anytime it rains, the water stays there, and it's a problem. So unless we are able to solve that problem that is caused by drainage, whatever one does there by importing material cannot resolve the problem. So what it means is that we don't have to get water into our pavements. And if they do get in, we must make sure that they drain away as quickly as possible. Now, on this slide, you will see 3 different ways water enter the road pavements. The first one is by precipitation from rainfall and other things on the surface of the roadway. The second is through seepage from the adjoining lands. And the third is through capillary action from under the road pavement. So what we need to do is to make sure that we tackle all these 3 aspects of moisture entering the pavement, and our pavement will be strong. Now, for drainage systems to work very well, we can liken them to what we have in our roofs. Sorry, in our homes. Now, in our homes, we have a roof that protects the homes from rainfall. I want to use this to describe how we can link preventing water entering our homes, to preventing water entering our pavements. So initially, you need a roof to keep the rainwater out of the house. You will need to slope the roof so that the water can run from the roof to the edge. You will also need a gutter to collect the roof water, and then it can take it to a collection point. You need a downspout to discharge the water that is collected from the house. Sometimes you need a cut-off trench to intercept water seeping into the basement from subsurface flow after you have determined that from maybe your geotechnical investigations. You also need a sump pump and underfloor drainage to intercept water moving up from the soil under the basement floor. So you will see from this slide what I have just described. You see rainwater falling onto the roof of the house. You have a roof catchment area. The water is sloped to the edge. It goes through the gutter to a collection point. It's taken through a downspout downwards, and everything is dissipated. So this is how one can tackle the effect of drainage on roads. Now, the road itself, it has, if you are talking about paved roads, it has a relatively impervious surface to keep water out of the base support.
Options are actually available.
And also to prevent surface softening of and erosion. The surface of the road is normally sloped transversely, so the water is run off to the edges of the pavement and the shoulder, where you have side ditches that collect this water and they convey it to a discharge point, like a convenient cross drain or adjacent stream bed. Now, in situations where you have side hill conditions that indicate presence of subsurface water, a cut-off trench or an under drain is installed to intercept the water and carry it away to a natural water course. Then also water seeping into the base from capillary action can be removed using transverse under drains discharging to side ditches. Very simple. Now, if we fail to meet these basic drainage requirements, it can result in pavement breakup, potholes, cracking, shoulder disintegration, base saturation, and eventually total pavement failure. Now, I have mentioned that we have drainage problems. So on the screen, you will see various points that we will look at to describe surface drainage systems. For surface drainage systems to work efficiently, you need a roadway cross-section. You need a crown in the shoulders, the side slopes, ditches, paved curbs and gutters, slotted pipe drains, culverts and head walls, catch basins and drop inlets, storm drains and manholes, and then outlets. These are all combined to make sure that drainage from our roads are efficient. So we'll take them one after the other. Now, surface drainage, as you can see, is a system that allows rainfall to drain from the pavement and shoulder into the roadside ditch. That's what normally about surface drainage. Now, to look at the roadway cross section, you can see from the diagram that it is sloped from the ground in both directions. It slopes. The water that drops on the road is moved away from the road surface over the shoulder into the side ditch or a gutter, so that it can be properly shed away from the road. This is a combination of the roadway, the shoulder, and the ditch. It's very important to maintain the cross slope in such a manner that the water is shed quickly away. The crown is also very important. Normally, the crown is discussed when you are talking about gravel roads or unpaved roads. It is a maintenance requirement to always maintain the crown, because when you don't maintain the crown and water falls on the road or it rains, the water may not be shed off quickly. It may stay on the road, and that will lead to potholes, soft spots, And we also even give safety problems because the water stays on the road and may cause problems for motorists. So it's very important to always maintain the crown of the gravel roads. The next important one is the shoulders. The shoulders are always sloped away from the pavement so that they can properly carry water away from the pavement surface. Where you don't have paved shoulders and you have edge shoulders, this should be sloped more than that of a paved shoulder so the water can be drained away quickly. At the same time, it must contain sufficient granular material to ensure stability. If you don't have granular material sufficient enough, it may be eroded. Sometimes on an embankment, rainwater is drained to the edge of the road surface and it's allowed to flow over the shoulder and then down the slope of the embankment. In a cut section, water falling on adjacent areas and on the road is prevented from entering the road surface by using a roadside ditch. So if you have an embankment, it's important to have the shoulder properly installed such that when it rains, the water runs over the pavement surface, over the shoulder, and down the side to a ditch. And in a cut section, you are sure that the water that is coming on the adjoining lands and from the road is trapped in the roadside ditch and doesn't get into the pavement. Sometimes when the backflow on the embankment is high, one can place a transverse ditch along the side slope to trap the water and convene it to a convenient point to avoid erosion of the embankment. Now, next one we look at are ditches. Ditches are man-made waterways which are provided so that surface water running from the road surface and over the shoulders can be led to a natural water course. Very simple. Most of our roads have ditches, and their function is to make sure that they collect surface water and take them to a natural water course. And there are two types. One is called a side or parallel ditches, which we normally have. So a side ditch collects the runoff from the side slope as well as from the road surface. Then you can also have a diversion or intercepting ditch. Now, a diversion ditch is constructed across a slope surface to keep water from flowing over that surface to minimize erosion and slides. Remember, I mentioned that when I was talking about the embankment. So it's a ditch that is constructed across a slope surface to keep water from flowing over that surface so that it can minimize erosion and slides. The next drainage factor we have is what we call paved curbs and gutters. Now, these are normally used to channel the runoff from the pavement to suitable collection points. And the combinations are common in urban areas and also suburban areas, and could be used in rural areas when shoulders and side slopes on roadways are easily eroded. You don't normally have them on rural areas, but in urban and semi-urban areas, they are always all the time around, and they are effective ways of controlling rainwater and draining them from the road surface. The next one is what we call slotted pipe drain. Now, it's a very efficient technique for removing surface drainage from the pavement by the use of slotted pipes, which are laid just under the pavement shoulder or pavement gutter joints. The top of the pipe is slotted to allow the direct entry of surface runoff and prevents water from entering the pavement structure at the joint. It's a very efficient way of just removing the water from the pavement and making sure that it doesn't enter the pavement, road pavement underlying layers, and is conveniently conveyed from the pavement to an outlet. The next one we look at is culverts and headwalls. We are all very familiar with road, this drainage structure. Culverts. is an enclosed channel that carries transverse drainage, maybe water, stream, etc., under a roadway or an embankment. They are also used to carry runoff from roadway slopes or any adjacent areas. The next one we want to look at is catch basins and drop inlets. Now, these are which are usually concrete or masonry boxes. For both of these structures, they have an inlet pipe and an outlet pipe, and they provide a connecting link to the storm drain system. As you can see from the picture on your right, the debris settles down and the liquid stays on top, and that can flow through the pipes. It's an efficient way of removing debris from the drainage system and helping to make sure that the drainage system is not clogged. The next one is storm drains and manholes. Normally, in an enclosed drainage system, the water is collected by inlets and then discharged into pipes that run underneath or alongside the roadbed. These pipes are commonly referred to as storm drains and are usually installed in urban areas. The drains can carry drainage for considerable distances and are usually straight sections at a uniform grade placed at intervals between manholes. Now, manholes are provided to provide access to the storm drain system for the purposes of inspection, maintenance, and cleaning, and are installed at junctions of 2 or more drains. Now, manholes and these drainage systems are normally found in urban areas, not in rural areas, where you have an enclosed drainage system. The next one of the surface drainage system is what we call an outlet. Now, the outlet discharge water collected from all the other drainage systems in either a natural or a man-made water course. Okay, so moderator, after this, you will notice that in addition to providing facilities for draining water from surface areas of the roadway, provision must always be made for the removal of water from underneath the road surface. Now, subsurface water can cause slope failure. It can cause slope failure, it can cause slip out, it can cause rock falls. You remember a couple of years ago, we had the rocks at near the Pedrazi falling off. This was caused because of subsurface water running through the rocks and weakening the rocks and making the rocks fall. So it's very, very important to look at subsurface drainage. And it's a major cause of pavement failure. In general, subsurface drainage can be divided into 2 functional classes. One we'll call interceptor drains, and the other we'll call under drains. Now, interceptor drains, they divert the flow of groundwater before it can reach the roadway natural soil. On this screen, you will see what I mean by an intercepted drain. You will see that you have the original surface of the ground, and then there was a cut. So as there was a cut, there is water flowing along the road, down there, and there's water flowing by capillary action. So an interceptor drain has been placed a distance away from the pavements, road pavement, and that is going to trap all the water flowing from, if you are looking on the screen, from the right into the intercepted drain, which is placed underneath the subgrade, which is an impervious zone. Then from there, it is taken to a convenient point and discharged. At the same time, because of that, the capillary water will be there before draining, but after draining, since there is no water there anymore, it will stop and there will be no capillary action. The next one is what we call under drains. And under drains collect and dispose of water from the soil directly beneath the roadbed. A typical example is what you have on the screen. So most subsurface drainage systems consist of a perforated pipe that removes underground water collected from the surrounding soil. So the system consists of a trench, as you can see in the diagram. There are two of them you can see in the diagram, in which a perforated pipe is laid, and the trench is then backfilled with an open graded aggregate. So around the perforated pipe, you have an open graded aggregate in the trench. Now, a cap of impervious soil is then placed on top of the trench to prevent surface water from draining into the system. A filter cloth to prevent fine materials moving through to the soils, the stones under, and also to clog the perforated pipe. Now, these under drains are typically installed under pavements or shoulders to eliminate moisture-related pavement distresses. The water from an under drain system is collected in a non-perforated pipe that discharges into a roadside ditch or a storm sewer system. Like this. This is what I mentioned, the filter cloth. It's an engineering fabric that is commonly used in subsurface drainage. So for example, after we have placed the coarse aggregates on the perforated pipe, we'll put this filter cloth on top of it before we place on top the natural soil material. And it's supposed to prevent fine materials going through and clogging the perforated pipe, as well as the stones that we have laid. As I explained earlier, most surface drainage systems consist of a perforated pipe that removes underground water that are collected from the surrounding soil. The water from an under drain system is collected in a non-perforated pipe that discharges into a roadside ditch or a storm sewer system. Quite apart from the under drain system, you have what we call French drains, and they are similar in performance to the under drain system, but they use coarser aggregates instead of the previous one we discussed. So they use large stones rather than the perforated pipe. So they don't use pipes, but they use large stones. So they allow water to seep through the large stones into the pipe and it's drained away. And it is noticed that for most cases, the French drains, even though they are very efficient, they are not as efficient as the previous under sub-drain I mentioned earlier. So to cap it up, Mr. Moderator, it is important to maintain pavement layers free of moisture. Base and sub-base materials may be designed in two ways. The first one is to minimize water entry, or two, to allow water to enter and exit free draining bases. Under this situation, it means that it's important to use open graded crash stone material or manufactured aggregate base. This produces a porous base material. So in conclusion, it's important to note that if you have a natural gravel material as a sub-base material, and you are building on top, and you are building a material, you are building using a material like crash stone base, which allows better drainage than the natural gravel material. It is important to allow the crash stone base to extend to the shoulder. So you have sub-base to the shoulder, crash stone base to the shoulder. If not, and you limit the crash stone base to only the carriageway width, and then you have on the shoulder natural gravel material, it's like you are trapping the water in the pavement. And there's a typical example in Ghana that caused a major problem where we have a crushed stone base, but the shoulder is a natural gravel material. So all the water that enters the pavement could not be drained away, and that led to early failure. Okay. Now, geosynthetic fabrics may also be used between the porous drainage layer and the under layers to prevent infiltration of fines. Thank you, Mr. Chairman.